Thank you for Professor Liu's kind introduction. And the reason I started the virology laboratory, major reason is because of him. At that time when I joined the National Jen-Ren University, we don't have virology laboratory. Can I have that? And so today I will focus on the virology part of Enterovirus, especially virus, genome, antigenicity, and the virulence. And our laboratory actually started in 1995 with the help of the Professor E.D. Strong from the Yale University. And before 1998, we had very few enterovirus, probably less than 30 per year. But in the 1998, we jumped to tenfold, 300 per year. And some year, we got more than 1,000 enterovirus isolations. And because of our past history, we still keep the viral cultures, so we still get the activity of enterovirus. And from this slide, you can see from the 1998 in the past 20 years, enterovirus isolation in our laboratory, the huge one is 1998. And every few years, we got a huge outbreak in the orange color here. And the most recent two large outbreaks here, 2008 and 2012. And as mentioned in earlier talk, we don't have EVS many in the recent, low activity in the recent years. And as mentioned, although we have the outbreak every few years, and we found out, according to the phylogenetic analysis, it can divide into at least 11 genotypes of the Enterovirus A71. And in the past history, we found that if there was new reemerging genotypes, we saw an outbreak. The first outbreak C2 and B4 and C4. And then we have two outbreaks of B5. But I will tell you later, these two B5 will have some differences in the genome. And because it had many genotypes, so one of the questions we ask is whether the antigenicity are the same or the different. And with collaboration with Professor Darren Smith from the Cambridge. And actually, this is the photo I took with him this June. It's the first time I visited his laboratory in the past 10 years, actually. We know for more than 10, but he came to Taiwan a few times, but this is the first time I went there, his laboratory. And he told me this office was previous tea room of the Dr. Watson and Crick. And how they identify the double-strand they were just talking in the tea room in this office. Now it's his office. And that's an interesting story to me. And with collaboration with him, we established the first EVA71 antigenic map. And we found out genotype B and C would have separate on the map. And particularly B5 also separate from the other on the map. So next question we ask is, what are the different antigenic determinants which determine this separation? And when we compare the B4 strain and B5 strain, we found out in the CAXI region, there were 3 positions at VP1 protein, and they have some variations. So we generated the reverse genetics virus with these 3 position substitutions. And we found out, for example, in the 98, the first position, if changed E to K, and you see it changed the, can you see the pointer? I don't think so, right? 有没有好的？因为不太清楚。OK 呢？ Sometimes better. You can see the switch of the position. And the middle one is the 145. Like here, you see the KEE to the KQE change the middle one. And you also see the switched position. And the same in the 164. So we think these three positions are determining the EVA71 antigenic properties. And these three positions are located near the receptor binding sites, and one of the Japanese scientists, two of them were here. So we think this may affect the receptor bindings. So we test these various mutants in these three positions. You can see they have the various binding properties. That's important. And on the right figure here, you can see the binding ability which correlate to the antigenic distance on the antigenic map. So these three positions are not only determine the antigenic property, but also determine the receptor binding. And the next I'm going to discuss with you the B5 I mentioned to you in 2008 and 2012. The whole genome sequencing showed there was separate cluster of the genome B5. And according to the full genome analysis, we compare the 208 sequence and 2012. You can see in the capsid region there were 4 positions with variations. The rest are located in the non-structured protein region. So we think in the evolution, amino acid substitution were major located in the non-structured protein region, which caused the reemergence in the 2012. And let's show you the B5 strain. And within the C4 strain, these were the data collected from the gene bank, the China isolate C4 genotype. And you can see also the variation located in the capsid region, only 3 positions. The rest are also located in the non-structured protein region. So this indicates the intragenotypic evolution of the Enterovirus 71 was located in the non-structured protein region. And another factor contribute to the evolution of Enterovirus A71 is the recombination, which was also mentioned previously. And in the past outbreak, in the C2 in 1998, we found out there were intertypic recombination between the C2 genotype and the Coxsackie A8 enterovirus. And B4 were recombination between B3 and the B2. And this C4 were actually between genotype C and B. So on the antigenic map, you can see that C2 and the C4 were overlapping each other. That's because of the capsid region were actually on the C2. And the 1998 were the sequence from the Enterovirus 71 and the Coxsackie A8. And when we compare the sequence before the 1998 and the 1998, we found that in the non-structured protein region, there was a position in the 3D polymers, there was the mutations. And these mutations before 1998 were thrown. So we did the reverse genetic virus and with substitutions. And we found that if we change it to the substitution before 1998, which was the sequence in the 1986, and thirdly, in the virus growth at 35 degrees, they were similar growth. But at the higher temperature, like 39.5, you can see much reduced titer of the viral growth. So this indicates before 1998, the virus cannot grow well in the high temperature. So after 1998, it grow better, so get higher viral load. And you can see that also they get a smaller plaque size at higher temperature with this thrombin substitution. And in vivo ICR mice model, you can see it 86 surrounding, you can see the prolonged survival and lower clinical score. So this indicates the recombination of the A71 and Coxsackie A8. This recombinant strain caused the large outbreak of 1998 in Taiwan, and the possible hypothesis is the temperature sensitivity was different. Another study, we also compared the isolate before and after the 1998, and in the 5' untranslated region, we found out a position at 158. If this is C, it's more virulent. If this is U, you can see the survival time is longer, survival rate is higher, and the lower clinical score. So this position in the STEM loop 2 of 5' UTR also contribute to the virulence of the EB71. Another study is when we try to establish the mouse model, we want to have a virulence strain. So we have adapted the EB71 in the mouse brain for 4 times. And this MP4 strain, you can see the apoptosis in the infected tissues. So the next question we ask is, what is the most virulence determinant here? And when we compare the sequence of the capsid region, we found out there were 2 positions, one in VP2, one in VP1. And these 2 substitutions, 4643 is our clinical isolates. And if we have 2 substitutions in these 2 positions, you can see the higher cytotoxicity, higher viral titer, and lower LD50. In contrast, this mouse adapted strain, if we change these 2 positions, you get lower cytotoxicity, lower titer, and higher LD50. So this indicates these 2 positions contribute in the mice virulence. And the mechanism for the 145 is probably due to the virus bonding. 145E increased the virus bonding, and 149N increased the virus uncoating. And the next study is we study the quasi-species among the one of the fetal case. The reason we study that because of the RNA viruses have low fidelity for the RNA-dependent RNA polymerase. So we may have the quasi-species in the different organ, different tissues. So the question we ask is whether there's dominant haplotype in the central nervous system tissues. And we were able to obtain a viral isolate from an autopsy case. And here you can see the specimen from the respiratory digestive system, or the central nervous system. And this isolate will sent for the next generation sequencing. And we performed the haplotype prediction. And from this slide here, you can see from the entry side, the stool swab or the intestinal mucosa, you get diverse haplotypes, more haplotypes. But in the CNS tissues, you get a major haplotype, which is shown in the red here. And when we do the haplotype frequency over 1%, you can see among this network program, you can see there were 2 major haplotypes among this specimen isolates. And these 2 major haplotypes have only one difference in the VP1 31 position. One is G, one is D. And when we compare the isolate from different various tissue, you can see from the CNS tissue, you get the dominant VP1 31G. And the others, they have fewer 31D. And when we compare the clinical isolate of other fetal case, or other mild hand, foot, and mouth cases, you can see the fatal case have higher proportion of the 31G compared with the mild case. So we think the 31G contribute to the disease severity and immunovirulence. So in conclusion of my talk today, this slide summary the virulence determinant analysis I just mentioned to you. The last one is 31G enhance the entry to the normal tissues. And I also told you the 5-part UTR. And there was one position and two position in the capsid protein and one position in the 3D determining the temperature sensitivity. And also I mentioned to you the amino acid substitution in the non-structural protein region, which may affect the viral fitness. And the summary of the genetic and antigenic analysis I mentioned to you, in the antigenic map, the B5 strand form a separate cluster on the antigenic map. And there were 3 positions in the VP1, 98, 145, 164, which contribute to the antigenic property and the bonding property of A71. And I also just mentioned to you the non-structural protein substitution, which contribute to the evolution of the EVA71, and intertypic and intratypic recombination also contribute to the evolution of the EVA71, and this may change the viral fitness and also affect vaccine candidate selections. So continuous surveillance of the virus, including the genetic and antigenic evolution, is recommended, and which may contribute to future vaccine development. Okay, lastly, I'd like to thank my member and also the collaborator and also the funding support from our government. I hope I don't delay too much so we can catch some time. Okay, thank you very much. Yeah.